In our lesson today, we're going to look at different shapes and determine if those shapes are similar to each other. And in order to figure out if they're similar to each other, a couple of things need to be true. And to help us out, we're going to start by looking at some similar triangles. I have these two different triangles here, triangle ABC and triangle DEF. And I'm going to see if these two triangles are similar to each other by looking at a couple of their qualities. In the first part here, it says, find the measures of all the angles in the two triangles, record the measurements below. So I'm going to use my pictures to come up with the angle measures. So I want triangle ABC first for these angles, triangle DEF second for these angles. Measure of angle A, right up here, I can see is 104 degrees. The measure of angle B, found right here, I can see is 29 degrees. And the measure of angle C, found right here, is 47 degrees. For angle D, the measure of angle D, found right here, is 104 degrees. The measure of angle E, found right here, is 29 degrees. And the measure of angle F, found right here, is 47 degrees. Okay, now that I've got their angle measures, the next thing that I'm going to do in part 2 here, it says find the measures of the three sides of each triangle, record their measurements below. So again, I'm going to use triangle ABC for these, triangle DEF for these. And I want to start with the length of side AB, so I'll come up to that triangle, and right here, AB, I can see is 6 centimeters. So I'll record that down here, 6 centimeters. Then I need BC. Side BC is right here, labeled as 8 centimeters. And then I need side AC. Side AC, found right here, is labeled with 4 centimeters. Okay, so now that I've got those side lengths, I'm going to do triangle DEF now, starting with DE. Side DE is right here at 12 centimeters. Side EF is right down here. EF is labeled with 16 centimeters. And then I need DF. DF is found right here, labeled with 8 centimeters. Okay, so I've got my angle measures, and now I've got my side lengths. And the first thing I'm going to do is look at those side lengths. In part 3, it says, compare the following measurements and be sure to put your answers in simplest form. So what they've done is set up 3 different ratios. They're comparing side AB to side DE, side BC to side EF, and side AC to side DF. And we're going to set up a ratio based on the values that we received from the table. AB was 6 centimeters, DE was 12 centimeters, BC was 8 centimeters, EF was 16 centimeters, AC was 4 centimeters, and DF was 8 centimeters. So my ratios right now look like 6/12, 8/16, and 4/8. What they want us to do is put these in simplest form. So I'm going to go ahead and simplify my 3 ratios. 6/12 simplifies down to 1/2. 8/16 simplifies down to 1/2, and 4/8 simplifies down to 1/2. So in the previous part, we recorded our angle measurements, and then we also looked at the side lengths, and we just set up 3 different ratios. And in part 4, it says the word corresponding means the same location of a side or an angle on 2 different shapes. So it's going to be in the same location, just on 2 different shapes. This says, how do the corresponding side lengths of the 2 triangles compare? So I'm going to go back to what we did over here. When I set up my ratios, I was actually setting up ratios of corresponding sides. AB and DE are corresponding because they're in the same location. Here's AB, here's DE. They're in the same location, just on 2 different shapes. BC and EF correspond. BC is the bottom of this triangle, EF is the bottom of that triangle. AC and DF correspond to each other. AC and DF, they're in the same location, just on 2 different triangles. So these ratios compared the corresponding sides. How were they related to each other? Well, we can see when we set up our ratios and simplified them, we got the same answer every time. Everything simplified down to 1/2. This means that the corresponding sides are proportional to each other. And so when we write back here, it says, how do the corresponding side lengths compare? That's what we're going to write. The corresponding lengths corresponding lengths are proportional. They are proportional to each other. In part 5, we're going to look at the angles here, and it says, what can be said about the angles of the two triangles, specifically the corresponding angles? So again, if I look back at what I came up with my angles, well, angle A was 104 degrees, and angle D was 104 degrees. And notice their location. Here's angle A, here's angle D. They're corresponding angles, and they gave me the same measurement. Angle B was 29 degrees, angle E was 29 degrees. Angle B was 29, angle E was 29. They're corresponding. Same thing for angle C and F. Angle C was 47 degrees, angle F was 47 degrees. They're corresponding angles. So when we look at these measurements, we can say that the corresponding angles are the same or congruent. Okay, so in part 5, the corresponding angles are congruent. Congruent just means the same or equal to each other. The corresponding angles are congruent. These are the two qualifications we need for two shapes to be similar to each other. The corresponding lengths have to be proportional, and the corresponding angles have to be congruent. Okay, when that's true, we say that the two shapes are similar to each other. Similar figures have the same shape, but they're not necessarily the same size. Okay, they're the same shape, but they're not necessarily the same size. Looking back at my triangles here, I just found out that they're similar because their corresponding sides are proportional and their corresponding angles are congruent. They're the same shape, but they're not the same size. Okay, so we've just discovered that two polygons are similar if the corresponding angles are congruent, again, meaning the same size, the same measurement, and the lengths of the corresponding sides are proportional to each other. Again, I need corresponding angles to be congruent and corresponding sides to be proportional. So underneath, I have 3 different examples here. I want to tell whether each pair of polygons is similar. I'm going to justify my answer by setting up a proportion and showing that the ratios are going to be equal to each other. So I have, in part A, I've got these 2 triangles here. And I'm going to set up my ratio, the first triangle to the second triangle. And I'm going to label them so that I'm consistent. I'm going to call that one triangle 1 and that one triangle 2. And I can see here that these corresponding angles are congruent based off of that arc right there. That means that these angles are congruent to each other. I need to find out, are the sides proportional? So what I'm going to do is set up ratios of corresponding sides. On the first triangle, I'm going to start with this measurement, 8. 8 corresponds to 4 on the second triangle. They're in the same location, just on different shapes. And I'm going to set that equal to another ratio of corresponding sides. On the first triangle, I'm going to use this length of 10, and that corresponds to this side length on the second triangle of 12. Okay? In order to be proportional, this has to be a true statement. Is 8/4 equal to 10/12? Well, I'm going to simplify my fractions to find out. 8/4 simplifies down to 2 over 1. 10/12 simplifies down to 5 over 6. Well, I can tell very easily by looking at these 2 ratios that these are not equal to each other. Since they're not equal to each other, then the corresponding side lengths are not proportional, meaning that these 2 shapes are not similar. They are not similar to each other. In B, I'm going to see if these 2 rectangles are similar to each other. I'm going to call this one rectangle 1. This is rectangle 2. And again, I can see right here that the angles are congruent. And in fact, I know all the way on my rectangles, they have 4 right angles. So the corresponding angles are definitely congruent, but are the corresponding sides proportional? So take a side from the first rectangle. I'll use this 4. 4 corresponds to 6 on the second rectangle. Then I'm going to set that equal to another ratio. I'm going to use 10 on the first rectangle. 10 corresponds to 15 on the second rectangle. Are these proportional? Are these equal to each other? Well, 4/6 will simplify down to 2/3. 10/15 simplifies down to 2/3. These are equal to each other, so I know that the corresponding sides are proportional and the corresponding angles were congruent, so these two rectangles are similar. These are similar to each other. Okay, in part C, I've got two more triangles. This can be triangle 1, this can be triangle 2. And again, I'm going to pay attention to my angle markings. This angle is congruent to this angle because they've got one slash. This angle is congruent to this angle because they've got two slashes. And this angle and this angle are congruent to each other because they've got three slashes. So the corresponding angles are congruent. Are the sides proportional? Take a side from triangle 1. I'll use this side of 15. What does 15 correspond to on the other triangle? Well, pay attention to the angle marks. 15 is between the 2 and 3 slashes. So between the 2 and 3 slashes here is this side of 30. 15 corresponds to 30. Equals. Take another length from triangle 1, 14 here. 14 is between the 1 and the 3 slash angles. Between the 1 and the 3 slash over here is 28. 14 corresponds to 28. And then I'm going to set that equal to my third side on triangle 1 is 16. 16 is between the 1 and the 2 slash angles. Between the 1 and the 2 slash angles here is 32. Are these all equal to each other? Well, let's simplify. 15 thirtieths is a half. 14 28ths is a half. 16 32nds is a half. They are all equal to each other, so I know that the corresponding side lengths are proportional. Therefore, these two triangles are similar. In the next section, we're going to use similar figures to find the value of a missing side. In question 8, these two triangles are similar to each other. I want to know, well, what's the value of x, that missing side right there? And so I'm going to do what I was doing before. I'm going to set up some proportions to help me figure out that missing side. Okay, I'm going to call this one triangle 1, and I'm going to call this one triangle 2. And the reason why I called this one triangle 1 is because I like my variable to be in the numerator. That's just my personal preference. So when I set this up, well, x is in the first triangle, and x corresponds to 20 in the second triangle. I'm going to set that equal to another ratio of corresponding sides. Okay, so on triangle 1, I'm going to use this side length of 9. And in triangle 2, that corresponds to a length of 12. And I've got to figure out in this proportion what the value of x is. So I'm going to have to always move toward the variable. How are we scaling here? Well, I'm not really sure how to go from a 12 to a 20, but I know that 9/12 can be simplified. So I'm just going to rewrite this. X over 20 equals 9/12 is the same as 3/4. And again, we've always moved toward the variable, so I'm going to be moving in this direction. I have to go from a 3 to an x. Well, to go from a 4 to a 20, I know I'm going to have to multiply by 5. And so I'll do the same thing up here. 3 times 5 means that x must have a value of 15. In number 9, I have two similar rectangles, and again, I'm going to try to figure out the value of that missing side there. And again, since this is where the missing side is, I'll call this rectangle 1. This will be rectangle 2. And on rectangle 1, x, it corresponds to, well, that's going to correspond to 4 centimeters on the second rectangle. And I'm going to set that equal to, all right, on the first rectangle, the other side length I know is 32 centimeters. And 32 corresponds to 20 centimeters on my second rectangle. And so again, I've always moved toward the variable, so I'm going to be moving in this direction. And I can see, to go from a 20 to a 4, I'm going to scale back by dividing by 5. And so I'll do the same thing up here in my numerator. 32 divided by 5, well, that's going to give me a value of x of 6 4/10. And I can see here that the units are centimeters. Always make sure to include your units if they're given. In the last example, in triangle 1, x corresponds to 5 in the second triangle. And then I used 18 in the first triangle, which corresponds to 6 in the second triangle. Pay attention to your angle marks. I have to move in this direction, but I'm going to have to simplify this down to 3/1. And then I'm going to scale by multiplying by 5.